Hey everyone, this is Matt with Learn Everything About Design, and in this video we're carrying on our series where we scan, process, and design a part for a car. Now in this case what we're doing is we're building this dual intake duct system that goes in the place of a fog light and turn signal or marker light on my Starion. Now the intent behind this is to understand, one, how we can use the scanner. Now we use the Creality Raptor Pro. Also, how we can process it, and then how we can build parts so that they fit in the OEM locations, figure out how we can use the Freeform tools, and then build this into a design that we can 3D print and test it out on the car. Now, the next step in this process is for us to turn these into solid bodies and figure out how we can mount them. So as I mentioned at the end of the last video, the two mounting points that we have in this common area are right here and here. Those mounting points are 2 of 3 that are used for the light system. Now, because the light is one big housing, all it really needed were those 3. Because we're dealing with 2 individual ducts, what I think is going to happen is the bolt holes for this one will be up against the metal, and then the bolt holes for this one will be a little bit above that, and then when these pieces get screwed down, they'll have a common piece of hardware that does that. So there's a lot that has to happen to kind of figure that out. But the first step is for us to turn these into solid bodies. So in order to make that happen, what I'm going to do now is unfreeze the edges that we froze. So we're going to go into unfreeze, double click this one, and then get rid of this stuff on the inside. So select it and delete it because we don't need it. And the next step of this process is to use thicken. But what I always suggest people do is when we are thickening freeform bodies is that we copy them. So Control C and Control V. And the reason for this is because we're direct modeling, so there's not really a good way to undo a thicken. So we're going to go into Modify, Thicken. I'm going to start with this one and thicken it 3 millimeters outward. Generally, 2 to 3 millimeters is going to be okay for parts like this. You may need more if you need more material in certain areas. But one of the benefits of using thicken is we now have control over the inside and the outside. So if we want to make it thicker in some area, so for example, right here, if I wanted to, let's say, pull this out and make just that one section thicker for strength reasons, we could do that. I'm going to say cancel. Remember that it does still need to fit in here, and it looks like we're pretty tight right there. It depends on how accurate that scan is. So I could take this entire loop and potentially the inside loop. So let's go ahead and find the inside loop, Control double click that, and use Edit Form, and then just shift the whole thing, let's say -1 millimeter, just to give it a bit more room. All right, so it still looks like it fits everywhere else okay. So I'm pretty happy with that. So I'll hide the bumper, and then I'm going to do the same thing to this one here. So again, my copy, modify, thicken, 3 millimeters, we'll say okay. Now obviously these are overlapping. That is problematic. This one's fine in terms of trying to attach, let's say a hose. We could build a lip on this after we go back to the design workspace. This one here, there's probably 0 chance that you're going to be able to connect it to something. So what this tells me is I'm going to hit Control Z before the thicken, and I'm going to take this edge and I'm going to move it forward. So I'm going to basically change that transition to happen. I'm going to go to a box display. Box display, this is really where we can see problems that we create for ourselves. So in smooth display, we can't really tell that this edge is overlapping this one, but I can tell just by the way the shape is changing that in box display, we've got a problem here. So I'm going to double click this edge and pull it forward a little bit, and then go back to smooth display. So that looks much better to me right there. And then we can just bring the bumper back, make sure that we're not touching anything. Again, this metal probably connects right there. It looks like we've got enough room. And now we've got enough of a straight section where if we put a little bit of a lip on there, we could put a silicone hose on and a clamp and be able to hold it. So now that we've got that adjusted, Probably a good idea because it no longer matches the original. Probably a good idea to, again, copy and paste it. So now we have a copy. So this one here is going to be break solid. And this one here is going to be intake solid. And the reason I say solid is because when we have a thickened body or a closed volume, it's going to convert to a solid when we finish the form. So that way I don't need to worry about the names after the fact. All right, so now we've got both of these thickened. They're obviously overlapping in the middle, but again, they're going to be sharing a bolt hole, so that might not be the worst thing in the world. But we need to bring the bezel back and see if we want to make any adjustments to the shapes. So this one obviously fits a lot closer to the bezel. So what we could do is modify, find wherever that little dialog is. We're going to set the pivot over here. And then I'm going to scale it just a little bit. All right. And that's going to pull it in. Always a good idea to go back to box display. Again, grab this one here. And the inside edge, you can kind of see it's like overlapping here. And we'll do the same thing on that inside edge. So we're going to reset the pivot. I'm going to put it over here somewhere. And then we'll scale that back and take a look at it in smooth display. Generally, I would say to not make modifications or too many modifications after you turn it into a solid. Sometimes you really don't have much of a choice because that's where we start to see some of these problems come up. So just in general, if you have to, make sure that you take both inside and outside edges. Use things like setting the pivot, maybe put it over here, and then using scale to just get it to the point where it's okay. And again, inside and outside edge, let's find it, control and double click. Reset my pivot point to this side because I don't want to move that side. And then just, nope. All right, let's select it again. Grab that. We're going to reset the pivot point over here. Basically what we're doing is we're scaling everything down to that location. And we'll just pull it in. Always double check the smooth display as well. Looks like now we've got some room there. And we can take the inside edge and the outside edge. I'm just going to pull them all forward a bit. Just get it a bit closer. So the shapes are looking pretty good. Again, we will deal with this in a little bit. And part of the thing I want to do is just make sure, kind of rotate this around, make sure that we're not hanging over any other solids besides that mounting point there. That's really the one that I need to deal with. Looks like maybe we could bring this edge and this one forward. And probably not a whole 5 millimeters. If you zoom in, then it'll change to 1 millimeter. That's probably pretty good. All right. Also remember the bezel is going to have to mount to these because that's how the bezel mounted to the light. So we are going to have some bosses for the bezel to mount to. This one is just a pass-through for the screwdriver. We could incorporate it as a mounting point, but in reality, it was just for adjusting the height of the fog light. This one here is going to be a mounting point. So we're going to, in the design workspace, we're going to end up cutting a little bit away from this duct, but also adding more so that we have a boss that we can screw into. So that looks okay. And I think overall it looks pretty good. So again, just some minor tweaks. Of course, we do have the ability to use the pull tool, which will allow you to pull freeform vertices down to a mesh. If you really wanted it to fit perfectly to the bezel, you could do that and spend the time to do that. For what this is, I don't think that it's really worth it. As you begin to build out parts, you may decide that you want to spend a bit more time and make them a little bit more refined. That's certainly fine. But for this concept, especially for doing an initial 3D print, I don't think it's really worth it. So we can see that we preserved most of the opening of that 50 millimeter hole. This one I think was 60 when we started. We had to go basically pinch in the section here to avoid some sheet metal. So we did have some sheet metal that we had to get around here. That was just an obstruction for the light. And again, in the back here, this panel, unfortunately on my car, is a bit rusted and corroded from battery acid, I'm assuming. So that could get cut out as well. So there would be a direct path for the air. A lot of times the battery is right above this location. That battery oftentimes gets relocated and put in the trunk or the back, just simply for more space in the engine bay. And that happens for larger intercoolers and things like that. This car, when I had an intercooler on it, the essentially the way that the intercooler worked is both the inlet and the outlet of the intercooler were over on the passenger side. It had a long tube, so nothing came over on the driver's side, but there were some pass-throughs in the sort of the bulkhead and area where the radiator is a core support that allowed for those to pass through. So it's pretty common for people to move the battery and stuff like that because the intake is on the driver's side for these cars. So I think the next step for us is to go ahead and finish the form. So now we're left with a couple of surfaces and a couple of solid bodies. So these two solid bodies still need a bit of work. We still need to make bolt holes that can attach them, or hardware that can attach them to the car itself. So that's a critical step in this process, is making sure that we can attach it to the car. There's not going to be an attachment for this duct on the sort of the right side as we're looking at it. Again, we could reuse some of these screws which hold the urethane bumper skin onto the metal bumper support. Most of those get rusted out on these cars pretty bad, and a lot of people cut them out and do all sorts of different stuff with them. But for right now, mine is still kind of screwed together and holding strong. But so, we only have those 3 mounting points. So what we're going to begin doing is creating some geometry based on the planes that we have. We could use mesh section sketches. We could use a couple of other techniques that we have available to us. But again, in reality, we're talking about these ducts fitting into an area. They're going to be 3D printed, and we're not super concerned about things like tight tolerances, right? We're not going to be really too worried about little nuances, making sure that these bolt holes are exactly like 45 millimeters apart instead of 46 and things like that. So it's going to take a little bit of a creative approach, but that's going to be our next step. And so let's go ahead and save our work so far, and then we will start to create those. So when we think about working with the mesh in Fusion, a couple of things come to mind. One, in order to build a plane off of the mesh, we really need to go into direct edit mode. That allows us to pick individual points on these triangles, and we could build out a plane here. Now, the reference that we have isn't super great. If we actually show the light, the reference on the light is better because we did a medium refinement NIR mode. So it's still not perfect because it isn't, it is an injection molded plastic part, and it's not perfectly flat like a machined part. But we do have maybe a little bit of better reference here. So what I would say is when we're trying to decide how to approach something like this, we have a couple of options. One is to build out planes and then create extrudes where those, the screws need to be. The problem with that is, as we build out planes by selecting 3 points on, let's say, a face right here, there is very little chance, next to no chance, that that plane is going to be parallel to the front plane, which means that in this case, 3D printing probably is not going to care. But if you were trying to mold or machine something, you would be just way off out of the pull direction for things like holes and bosses. So another method that we could do is to try to create a plane that is close, but is an offset plane from our front plane, our default XZ plane. Now, we're not going to really be able to snap it to here unless we go into direct edit mode, which is something that we can do. But that's going to give us a plane in the right location that is going to be perpendicular to our top plane and parallel to our front plane. The downside to that is it's just a couple of extra steps. The other way that we could do it is by creating an offset plane and then just trying to visually get it close. So we'll create a plane, we'll resize it, and then we'll modify that plane. So once we resize it, we can maybe start to drag it. And you can see here that 110 millimeters is not enough, 112, 113. So once we get to 114, now we're right about where that face is. 115 is a little too far. 114 and a half is kind of right there. So again, for 3D print, not super precise. We're not talking about, multiple decimal places of accuracy for a machined part. This could be good enough for what we're doing. So I think I'm going to use this for my first plane. And then I'm also going to show the process of doing that with Direct Edit. All right, so we're going to go into Direct Edit. We'll select this mesh body. Remember, it's unselectable, so we can't pick it on the screen. And from here, we're going to create an offset plane. We're going to start with the front plane. We're going to say to object and actually hit cancel. We're going to make it selectable. So again, offset plane, front, to object, and see if it'll let us click a point. So you can see here it's not letting us click any of these points. Let's do, yeah, that's not going to work. So if we do, let's see, plane at 3 points, it lets us pick those points. So that's pretty close, and then we would need to use that as a reference. So I don't think that this is going to work very well for our needs. I don't think that that second plane is super helpful. So I think what I would say is probably the original method of just doing an offset plane. And then we're going to resize it. Resize it over here. See where it falls, and then just continue to modify it. So we want to put it yeah, we're getting closer. So I'm going to rotate this around. Looks like I need to resize it a bit. So right there, about 133, 134. That looks like it's going to be pretty good for that one. Go ahead and drag it up. And then we'll just do the same thing for this bottom one. All right, so obviously not nearly as precise as like creating a plane in Quick Surface and using a reference on the mesh. But again, this gets us pretty close. I'm going to go to about 140. I'm going to resize it and make sure that it's roughly in the right location of that spot. And then we'll go ahead and just rotate so we can see it. So let's go to about 120. All right, so about 118. Yeah, 117, that looks to be right about right. All right, so now this plane here we don't need, but now we've got plane 1, which I'll resize over here. Yeah, it's going to be our first mounting point. We've got plane, this plane here for that one and this one for that. So now that we've got those, let's do a quick save. And then we can start to build out some shapes off of those. So let's go ahead. I'm not really gonna worry about doing mesh section sketches, and mainly because we don't really have a true hole for this. So this upper section, this is where the bezel mounts, and you can kind of see it just rolling in. For things like a cross-line laser scan, we would have much higher resolution here. For a medium NIR scan, I'm not really pulling out much data for a precise location. So what I'm going to do is I'm just going to create a new sketch. And I'm going to create a circle, so C on the keyboard. And the circle is going to be the mounting boss. Looks like I'm going to make it about 12 millimeters. And just visually kind of get it in the right spot. And I'll create another circle. So this is going to be passing hole for the screw. I'm going to make it 7. And that's going to give me my location for the boss. So again, I'm not fully defining it, but that's going to get me close. We're going to go back, create another sketch over here. And we're going to use the same same specs. Now I could make a mounting tab, like an actual rectangle here if I wanted to, but I think this sort of screw boss is going to be enough for us. And then we'll do the same thing down here. I really wish Fusion didn't always go to the origin. That's kind of a pain. So let's do 12 and 7. And I'm going to hold down Control so it doesn't snap to anything. And then finish the sketch. So I want to go back and make that mesh unselectable. Notice that we've got, they're kind of divided now. The mesh, all the meshes used to be up top. And that's because when you do things like direct modeling or modify a body or something, they're always restructuring the bodies folder in the browser so that the newest one's at the bottom. Unfortunately, it's just kind of the way it works. All right, so now we've got those locations. Now we've got essentially these pieces. So what I'm going to do to get started is I'm just going to extrude them out. So we're going to take let's see. Let's just see how far we want to go. I'm going to make it a new body. And maybe take it to, yeah, we'll take it to right there. And we'll do the same thing with this one. So we're going to extrude it out. Don't want to go all the way through the front because remember the bezel is going to be there, but we'll create that as a new body. So this will give us an idea of where we need to remove some material, in order for it to mount. And then we'll do the last one over here. This one is going to be solely for this piece. It's not going to share it with the other side. So this one, maybe we'll go right there. Yeah. All right. So now we've got a couple of mounting points. The two over here are going to have to get split in half. Part of them will go to this piece and part of them will go to this piece. Just looking at the geometry, what I'm thinking here is that the back portion, so if I split this in half, the back portion, what I'm going to do is I'm going to extrude or extend it out so that it meets this body over here and connects. And then the upper portion, I'm going to extrude or extend out so that it meets this one here. So that way the back half can connect to this bracket and the front half can connect to this one. We'll have to cut out a little bit of the duct space. I could go back into the form and adjust it so that the transition happens a bit sooner. Probably not a big deal, but we could go back and we can make some adjustments there if we needed to. On the other side here, basically the idea is something similar. So we're going to create a sketch. And when we use slice, we can see where it lines up to this shape. And what I want to do is basically just come over, find this position, and come over, and then just connect these together. Make sure that's horizontal and tangent. So sometimes you'll find that these edges get stuck. So it's over-defined because this is perpendicular with that, that's perpendicular with that. So as long as this one is tangent, we should be able to fully define these. If this one is fixed. Let's go ahead and make it tangent here. And really what we just have is this piece floating out here. So a couple of things of note. If we were to have this sketch profile here and just extrude it, we could say extrude to object, and theoretically, we could just have it be a solid. If the profile isn't completely encompassed in it and this doesn't work, then the next thing that we would try is, I'm just going to drag this through because it's underdefined. I can do that without going back into the sketch. I am going to bring this up to the front face here. And I'm going to say create a new body. Really, I want to join it to this. But the reason I'm not doing that yet is because I need to get rid of all this extra stuff on the inside. Now, there are two ways that we can do this. A simple way is to just combine everything together and then select the stuff on the inside and hit delete. Now, Fusion's pretty good at patching that stuff. The other way, if that didn't work, is to do something like a split body, and then we could split that extruded body with the inside face of that duct, and then it would work. So now we've got a big block connected to it. We could use fillets, and we could round this, round this off for a little bit more strength if you want, even back here. And now that's a mounting boss. Not exactly ideal for a manufactured part, but a 3D printed part is certainly going to be okay. Now, in reality, what you would end up doing is probably making this a bit shorter. So, for example, let's see, which extrude is it? This one. Because the mounting boss is back here, there's no reason that this piece needs to be that long. And then, because we extruded up to that front face, it'll automatically take care of it for us. We can come back and add that. Maybe reduce this down. So there we go. All right, so I think that'll work for this concept anyways. If we need to go back and make some refinements or move things around, we may change our mind, but for this concept, it'll work okay. And we can do some on-model support when 3D printing it. So for example, if we're printing, because this is a planar face on the back, we start here, then it'll have some support that has to come up to support it there. We could do a large chamfer on the side here, and then that would help with that. So for example, if we go back in here and remove that, and we do, let's say, a chamfer on this edge, then we could potentially get away with less support. What I would say to that is to be a little bit careful, because this needs to mount to the sheet metal, right? So I'm going to use press pull, maybe make it a little bit thinner until I'm happy with it there. All right, so we use the back of the light, which its alignment could be a little bit off with the bumper here, so probably best to use the back of the that spot on the bumper. Now, obviously, getting a screw to that location would be pretty tricky, but it is possible. I also may want to, I'm going to show this sketch. One of the benefits of, I'm going to right click on this sketch and say find in browser. One of the benefits of leaving these underdefined is I should be able to move it and have all the features rebuild. So for example, we use the back of the light as the reference for where that circle or where the mounting hole should be. But if we find that we need to move this up, I'm going to hold down Control and just kind of move it until I'm happy with that location. Because we deleted the stuff from the inside by selecting faces and hitting delete, as long as we don't get to a situation where that extrude doesn't extend through the inside of the body anymore, then we should be able to just make those little tweaks. I'm going to hide that. Now for the other ones, I am going to go ahead and, let's say, hide this one, and now has that mounting tab attached to it, but this one over here doesn't. I am going to hide this and just, that looks like it's in the right location. That looks like it's in the right location as well, or at least pretty close. All right, so again, these need to be split in half. They look like maybe they're a bit far back And again, that's an alignment thing with the mesh. So I'm going to use press pull and just pull them forward a bit. And it looks okay. Just looks like it's 1 millimeter off. All right, so now we need to split these in half, or at least close to half. So this can be done a couple ways. We can create some midplanes. So for example, on the top one here, I could do front and back, create a midplane. Then I could do split body. The tool is going to be this midplane. And now I've got a front piece and a back piece. Another way that we could do this is with a sketch. So for example, if I create a sketch here, and I project this, let's say project the whole body. Then I've got a midpoint reference here. And I could do the same thing. So split body, my reference is going to be that line. And then I don't have an extra construction plane to deal with. So both methods work fine. You can also split it with a surface, or if you have some other geometry that you want to use, you could do that. But again, you kind of just have to pick whichever method works best for the geometry you're using. So now we've got this break solid, and this piece here, I'm going to double click on, or single click on and hit V and V. So that's basically just visibility that's hiding them. So now I need to connect these pieces to that. And what we're going to do is very similar to what we did before with the other one. Remember, they're on different planes. So I just need to start a new sketch back here. Again, snaps back to the origin. I'm going to use slice, and you'll see that this one is actually quite a bit further away. So we may not need to carry it all the way, but I'm going to go ahead and do that anyways. I'll come back to here. We'll make this one horizontal. We'll make this one tangent. And then it's a bit overkill, but I'm going to go ahead and extrude up to the front. Sometimes you'll find when you're in perspective mode that the rotation gets a little bit laggy. So if that's the case, sometimes you can just turn off perspective mode and just go to orthographic mode. This will let you rotate a bit better. It lets you zoom in pretty far because you don't have perspective to deal with. I don't like looking at my designs like that. So if I'm working on a design, I don't like that. Selecting the back face here can be pretty tricky. So what I do is hold down the left mouse button and then select it from there, hit delete, and you can see that it patched the inside. Now, these are kind of what I would consider kind of like hacky tricks, but if you're making a 3D printed part, a lot of times you don't need to worry about the timeline or like spending a bunch of time with these little things where your main design or the majority of the thing that you're designing here is just an organic freeform shape. I don't need to spend a lot of time to get those to be perfectly in place, fully defined sketches, and so on. So I'm going to go ahead and, again, slice. This one I'm going to come up, over, and down. We want to make sure that both of these are tangent. We can make this perpendicular, and then just, again, not too worried about fully defining it, just making sure that I can extrude this. I'm going to go to this front face, and we'll join it all together. And now, again, in reality, doing an extrude up to an object and allowing it to terminate perfectly at the object is best. But when you're dealing with sort of these funky shapes in 3D, oftentimes that can just be a bit cumbersome. So again, this is more of a direct modeling approach, even though we've got history turned on. Leaving history turned on means it's easy to go back to sketches and things like that. Now, in terms of this right here, and what I mean by this right here, I mean like the section where we have a potential problem. What I am going to do is take this, and I'm going to take the whole thing. I'm going to extrude from this face because we moved it a millimeter, and we're going to be coming out this direction. So as we look at this, we can kind of see the amount of material that needs to go away to be able to access this. What I'm going to do instead is I'm going to go up to Object and select this face. I'm going to use this Adjacent Faces, and I'm going to join it together. Actually, you know what? Let's do Cut and see what that looks like. All right, so that's how much we need to get rid of there. I'm going to hit Cancel for right now, and I want to take a look at the extra piece that's on here. So we can see that extra piece. This is going to be where that sort of front section is. I don't really love the idea of just cutting out that corner. So I'm thinking what I want to do is make an adjustment to the form. So before I do that, always save. You don't want to get stuck in a position where you make a change and you crash Fusion and then you can't get back to where you were. So we're going to make sure it's saved. Once it's saved, we're going to go into this freeform body. Remember, it's thickened, so we want to make sure that we move the inside and the outside together. I'm going to do this in box display mode to make sure that I don't get in as much trouble. And I'm going to see if I can't pull this in. Let's just take a look at it. So obviously not ideal, but I'm going to take the inside edges here and just kind of manipulate things a little bit and then take a look at it. All right, so basically we've got that extra little bump in it. If we bring the bezel back, you're probably not really going to notice. You can see it's starting to peek through over here, but we could thin that out if we wanted to. Just make it a little bit thinner on the front. And yeah, just remember we're manipulating the inside and the outside, which means that we're going to have an inconsistent thickness. For 3D print, it's not a huge deal, but for other geometry, it might be. So essentially, this cylinder is going to have to get cut out from the side of this. And that's the problem that we're dealing with because we don't want it to cut all the way into the inside. So what I'm trying to do is just manipulate it so that it doesn't look so bad. I'm going to kind of pull this in, pull that one in. Again, box display is going to be your friend because things always look different in box display. And let's grab this one here. Notice I'm not doing much with the outside. I'm leaving it a bit thicker, and partially because there's a screw or a mounting point in that location. So I'm not as concerned with trying to keep it a consistent thickness there because having a little bit of extra material can help. All right, so I think that's better. We still have to remove a little bit, but I think that's okay. I didn't do too much damage to the shape. Looks like it might have a little bit of overlap with the bezel because before it was on the outside of the bezel and now it's not, so probably need to pull it back a little bit and maybe even pull this one back a little bit. All right, so just double check. Again, not perfect, but probably so minor that you wouldn't be able to know. Of course, a way around this would be to design our own bezel. Not really something I want to do for this part, but it is a possibility. All right, so now this piece is okay. This piece, we need to remove material. So what I'm going to do is I'm going to say, I'm going to take that, I'm going to extrude it, and we're going to go from this face here, and we're going to pull all the way through. Oh, from here. Oh, come on. Select. All right. Let's try again. This profile, starting at Oh my goodness. Let's just start here. Go all the way through. And the object to cut is going to be just the brake duct here. So that's going to leave. Now, in reality, this is a perfect fit, which means that it's not going to fit if we 3D print it. But we could increase that a little bit, or we could decrease the outside diameter of this. And I'm thinking I want to decrease the outside diameter of that. So Q, I'm going to say minus 0.5. It's actually moving it. I don't like that. All right. Let's try this again. Minus 0.5. And instead of automatic, let's say new offset. The problem with doing a automatic, actually, because it's the diameter, let's do minus 0.25. The problem with doing an automatic offset is it tries to first edit the original feature. That's not going to work great in this case. All right, so there's the cut that we got. And I think I want to do a fillet there. And maybe a fillet there. It's just for strength. All right. So now we got those two tabs. We need to take care of this one on the back as well. I don't really want to modify the shape that drastically in that area. That is actually hidden behind the bezel pretty far, so we could modify it if we wanted to. You know what? Let's go ahead and do it. All right, so we're going to edit the shape. Again, box display mode. I strongly urge you to do that. I'm going to select these faces on the inside as well, and we're going to use edit form. So kind of bring this in, maybe to there. Take that inside point as well. It's leaving the outside, but we'll just manually move that. Take a look at it in smooth display. Bring the bezel back just to make sure. Yep, so you see when we move it too much, it's starting to get kind of to the outside of that bezel, which I don't like. All right, I'm going to do Control Z. I'm going to put it back where it was. So I'd rather have it on the outside of the bezel, and I'll just deal with the screw hole because that's going to be completely hidden on the inside. So I need to find that sketch. Let's see which one it is. It's this one here. All right, so we're going to take this. We're going to extrude it. We're going to go from this face, and we're going to go forward. I want to include, let's rotate this around. I'm going to include the inside in this profile. So come back up here, we'll include that. All right, so this is going to get cut only from the brake duct solid, and it needs to go further. All right, and then we're going to new offset minus 0.25. Just so it fits. Hide the sketch. And we'll hide that. All right. So again, that's pretty far inside, so not really going to be a big deal in terms of the design. All right. So now we've got these two pieces, and they need to get connected to the other duct. So they need to get connected to this one. This is going to be quite a bit easier, but we need to make sure, again, that we're not hitting any issues, and I don't think we have any. I think everything's pretty flat in there. All right, so we've already done this before, but we're going to go ahead and create a sketch. We'll slice to kind of see where we're going. We'll do a line, and then come back. So we want this to be tangent. We want these to be horizontal. And then we'll extrude that profile. So this is going to come, let's see, all the way up to this front face. We're going to join it together. And then again, use our cheap trick of deleting faces. Now, I will say that using the delete face thing, it works perfectly fine. I would not do this if I was trying to build a robust CAD model, one that would update easily if I made dimensional changes. If my designs are, the starting point is a freeform model based off of a mesh, oftentimes that is not as big of a concern to me as if it was a true prismatic part. So it's just kind of something that we need to keep in mind. For this one, again, we'll come over. We want to make sure that these are tangent. Not a super requirement, but I just, for my own mental stability, I like to make sure that they are tangent and perpendicular. And then we'll extrude it. Same process again. Go up to object on the front. We will join it all together. And anywhere it sticks out, select and delete. Now this one, there may be a small section. There's like a little gap there. So again, hold down Shift, left mouse button, find that face, and then hit delete. And then we'll add some small fillets. So we'll do 1 millimeter. And then I'll just add a couple more here. All right, so in reality, we now have a single screw over here. I think there is enough clearance that I could get the screw in and get a screwdriver on that and tighten it without having to remove more material. So I think I'm going to leave that one as is, and hopefully that doesn't bite me. These two now, we've got the sort of overlapping sections, so I can put a screw through both of them. That will hold this duct on, and this one, they'll be held together, and that third point way over here. So let's save that. And the next thing that we need to do is we need to incorporate some bosses so that the bezel can screw on to these. So we've only got 2 locations to make that happen. So we've got one here. We can see that the solid body is slightly coming through that spot. We talked about that during the design. And then over here, we got kind of the same thing. So what we need to do is we need to add some material for adding that boss, and then we need to remove material where it's overlapping this. So we're going to go about this in the same way that we did by creating an offset construction plane, and go ahead and look at it from the side. Basically, I'm going to pull it back to about where I think it is, and I'm going to resize it. I don't think that they're on the same plane. Yeah, they're definitely not. So get this over here. And then we'll just edit this. So 100, let's try 115, 116, 117. All right. So again, not incredibly precise, but for what we're doing for this 3D print, that's perfectly acceptable. And we'll do this one more time. And let's just try 100. I will resize it until we're at that mounting point. That's pretty close. So maybe 97, 96. Yeah, I think 96 is going to be fine. All right, so similar process. Now we've got these planes. We are going to, these are actually going to be bosses for screws to thread into, where the other ones are actually threading into something on the car. So this hole has got to be a little bit smaller. I don't know the size off the top of my head, but I think it is a 6 millimeter screw. And so I'm going to make this 4 millimeters, and then I can always drill it out. And then I need to make a boss that is, let's say 14 millimeters. All right, so now that we know where that starts at, I'm going to hide the mesh. And essentially, so everything forward of here is going to get cut. And then we need to build this boss backwards so that we have enough for a screw to thread into. Now, unlike the mounting tabs, this boss doesn't really need to have all of this extra material and the tab that goes over, but we just need to make sure that we have it's connected well enough to the rest of the ducting that that it'll hold. So we're going to say 10 millimeters. Okay. I'm going to hide the sketch. I am going to give it a semi-large fillet. Again, just kind of for strength or structure. And then I'm going to round these off. Let's try 1 millimeter, see if it'll work. Yeah. All right, so if we bring the bezel back, so the bezel should fit there. Looks like maybe a little bit. Now, with a 3D print, I can always file or cut that with a razor. That looks pretty good. A little bit of overlap there, but again, I can always file that down. I'd rather have it be a little bit tight than a little bit loose for this. And we'll do the same thing over here. So one more sketch. We will do, I think we did 4 in the center. I think we did 14 on the outside. And it looks pretty good. All right, and then from here, again, what I'm going to do is I'm going to go ahead and join it together, 10 millimeters. And then that same sketch, we're going to pull, why does it have 3? All right, and pull that forward and cut it out. So then we'll give it the same sort of fillet. Let's see if it'll let us. It does not like this. Why doesn't it like this? Because there's not enough material there. All right, we'll deal with that in a second. If there's ever a little bit of material left over, again, select and delete will kind of clean that up. I'm going to do a, small fillet here. Do we do 1? All right, and then for the fillet here, if we want to go a little bit further, let's say 11 millimeters, that should give us more room to add a fillet. So basically what happened before is that edge, look at that, that edge was disappearing too much. So that's why it wouldn't let us do that large fillet. All right, so the back side of these aren't the greatest. I mean, I wish that I could just make this all one piece and had a printer big enough to print it. Printing it in a vertical orientation could be possible. I do have a K1 Max it might fit on, but again, breaking it up like this, we're going to use a common bolt location for the middle, and now we've got these, these kind of bosses hanging on the side that will allow us to screw the bezel on, and then we'll have those paths. Now we could print this in something like a PLA CF or another material that could hold up to the use and abuse on a car. The first print that I'm going to do is just going to be PLA. I'm going to make it a bright yellow so we can see it a bit better, but just usually what I do is do some testing when I have something like this. So that way a hyper PLA prints pretty quick, quality is pretty good, and generally they're fairly strong. So if we were to bring the bumper back and maybe take a look at just changing the color of these. Let's go to Fusion Appearances, and I'll just go to a plastic. Let's do an ABS white. And let's go ahead and actually let's do a different color for the bezel. Just so we can see it a bit better, I'm going to use green on the bezel. And then Control and 4. So this is basically what we have. We've got 2 pieces. We're going to 3D print individually. They theoretically should screw to the car, and the bezel should screw to them, and everything should fit in the factory location. So now's the point where we get to 3D print these. So let's go ahead and save it. We are about an hour in at this point. to this video, obviously a couple hours into the total thing, but we're about an hour into this video, which means that we should probably stop it here and pick up in the next video. Now, as far as like setting these up to 3D print, I don't think we need to spend a ton of time going into that, but the basic process here is for us to save as a mesh. I'm going to send it directly to a print utility, in this case, Bamboo. And then what I generally will do is during the design process, if it's a part for 3D print, during the design process, I will go and think about the orientation of the part when I'm creating it. Hold on a second. This came up on another screen. Okay, let's see if we can bring this over. So with a part like this, obviously you could print it in all sorts of different orientations, but what I think makes the most amount of sense is to print it like that. Now, when I say most amount of sense, I mean because that is a planar face based on the way we designed it. Nothing else on this is going to be able to stick to the build platform with any sort of I mean, really, nothing else is flat, so there's nothing else that would work. So this is really the best option that we have. We will need to enable supports. Generally, what I do is an auto tree support, and it's going to end up supporting these mounting bosses. The rest of the duct probably will be okay. This section over here looks like it's going to need something. But the good news is the inside isn't going to have any support, which means that it's going to be nice and smooth. The outside, the areas that you won't see, those are going to be the ones that have the support. So exact same process for the larger duct. We're going to go ahead and send this one. This one's going to take 2.5 hours to print. The larger duct, probably 3.5 hours. Going to go ahead and get those printed, and then we can do our install and wrap-up video, as well as for me to re-record the intro video because I accidentally didn't turn a microphone on and I recorded for an hour. So I need to redo some of that initial content as well. But let's go ahead and send these to the printer, and then we'll check in when they're all done. Now, if you have any questions on anything you saw in this video, any of the previous ones, please leave a comment. If you like this, consider subscribing. We do a lot of more intermediate and advanced type content on this channel. And so we dive a bit deeper into these topics. And if you like that and you like these long-winded explanations, then consider subscribing. But as far as this one, that's going to be it. So as always, thanks for watching, and we'll see you in the next one.